Welcome to This Explainer. Look, we are diving straight into literally one of the most frustrating universal pain points in all of software development today. If you've ever wondered how modern tech giants keep their massive apps running so flawlessly, this is exactly where it begins. We're breaking down how two absolute powerhouse tools solve an age-old developer dilemma perfectly. You know the drill. You write some absolutely brilliant code. It runs flawlessly on your local laptop, and then it completely breaks the second it gets deployed to a production server. It's the infamous, well, it works on my machine, excuse. And honestly, it's a massive headache for everyone involved. So here is our agenda. Number 1, the works locally problem. 2, Docker packaging the environment. 3, images and containers explained. 4, the crash and scale problem. 5, Kubernetes managing the chaos. And 6, real-world scaling with Netflix. Section 1, the works locally problem. Why code breaks in production. Okay, let's validate that frustration for a second. Why does this environment mismatch even happen? Well, think about your runtimes. You might be coding away locally using the shiny new Node.js version 20, but your production server, say it's on AWS, might be rocking Node 18. Why? Because older versions are generally more stable, well-tested, and have fewer vulnerabilities. The catch is, if you use a feature that only exists in Node 20, your AWS server literally doesn't support it. So the application crashes or behaves totally differently, just because the underlying environments don't match. Section 2, Docker, packaging the environment. Taking the entire setup with you. This is exactly where Docker steps in, and it's a real game changer. Docker essentially says, hey, let's just take your perfectly working environment with us. It grabs the absolute bare essentials needed to run an app. First, a minimal OS, like a stripped-down Linux. Next, your specific Node.js runtime. Then, your actual application code. And finally, your dependencies, all those external packages your code relies on. Docker takes those 4 crucial pieces and bundles them tightly together. Section 3, images and containers explained. From static file to live server. To really get Docker, you just need to know 2 key terms. First up, the image. Docker compiles that minimal OS, the runtime, the code, and the dependencies into a single static file called an image. Think of it as a perfectly locked-in snapshot of your local setup. If you use Node 20, that image has Node 20 baked right in. But an image is just a static file sitting there. When you actually execute that image on your AWS server, Docker spins up a container. The container is the live running instance of your app. And this completely eliminates the works on my machine problem because the container basically is the machine. It doesn't matter if your AWS server was built for Node 18, the container brings its own Node 20 environment along for the ride. Section 4, the crash and scale problem. When Docker isn't enough. Right, so Docker completely solves the environment mismatch, but it creates a new headache. It doesn't manage those containers long term. What happens when your app goes viral? Or if a container just randomly dies from a weird code error? Docker by itself can't auto-restart a dead container. It can't magically duplicate containers to handle a massive spike in traffic. So you've got a perfectly packaged app that is now completely overwhelmed. Section 5, Kubernetes managing the chaos. The orchestrator steps in. To keep multiple containers healthy and survive the chaos of massive traffic, you need an orchestrator. Enter Kubernetes. Now here's a fun fact. Kubernetes doesn't actually interact with your Docker containers directly. Nope. Instead, it wraps your Docker container inside a management layer called a pod. It's usually best practice to keep just 1 container per pod. That way, if something fails, Kubernetes knows exactly which specific container died without any guesswork. Think of Kubernetes as your hyper-vigilant manager, and it's got 2 absolute superpowers. First, auto-restart. If a pod crashes, Kubernetes instantly detects it and spins up a brand new, healthy pod in under a second. No human needed. Second, auto-scaling. If traffic spikes and a pod is struggling, Kubernetes dynamically duplicates that pod, creating a bunch of replicas to share the heavy lifting. Section 6, real-world scaling Netflix. Handling the Dhurandhar movie drop. Let's look at a real-world heavyweight to see this in action, Netflix. Netflix doesn't run one giant, fragile server. They use a microservices architecture with over 700 different highly specialized services. They have one container for logging in, another strictly for video playback, and another for handling your credit card. So if the payment service crashes, whatever, you can still binge your show. So picture this. A highly anticipated blockbuster movie, let's call it Dringendar, drops at exactly midnight. Suddenly, millions of users flock to the app and hit the playback service at the exact same millisecond. For traditional server, that's game over, a total crash.
But with Kubernetes, it's a different story. It sees the playback pods getting completely hammered. It doesn't bother the payment or auth pods, it strictly targets the playback service. It dynamically auto-scales those specific containers, multiplying them up to a set limit. It's literally building massive infrastructure on the fly just to absorb the hit. The timeline here is wild. Kubernetes spots the spike and adds those new containers in under 5 seconds. But, and this is super clever, when the movie ends and traffic drops, it doesn't just instantly delete the extra containers. It waits 5 to 15 minutes after the rush is over before scaling down. Why? Because people might just be grabbing a quick snack, and if they come right back to start another movie, Kubernetes wants that infrastructure ready to go without having to rebuild the whole shebang. So, here is your big takeaway. Docker packages your code so it runs perfectly anywhere, wrapping it in a portable image. Then Kubernetes takes that package and orchestrates it, restarting it when it breaks and scaling it dynamically when the whole world logs on at once. So if Docker builds the perfect environment and Kubernetes scales it infinitely, what are you going to build next? Thanks for hanging out with me on this explainer. I'll catch you in the next one.